Okay. November 2021, paper 3, variant 1. Okay, question 1. Using the ruler, can I determine the length of this piece of wire? Yes, I definitely can determine the length of this piece of wire. Because the wire started at what? At 1.6. Started at 1.6. And it ended at 14.8. 14.8. So can I subtract 14.8 minus 1.6? Yes. 14.8 minus 1.6, which gives you a final answer of 13.2. 13.2. The student folds the piece of wire and measures its mass. State the name of an instrument that can be used to measure the mass. It is a balance. Student determines the volume of the wire. This is the volume of the wire. Determine the volume by the wire used this information. How can I find the volume? V2 minus V1. V2 minus V1. V2 was 22 and V1 was 18. Again, if you zoom in, okay, if I zoom in, we always take the volume of the water. How can I take the volume of the water from the bottom of the meniscus? From the bottom of the meniscus. So the volume is actually 22, not 23. And the volume in this figure is 18, not 19. Why? Because we take the volume, we take the reading from the bottom of the meniscus. One of the precautions we said in paper 6, from the bottom of the meniscus. So it's 22 minus 18. 22 minus 18, which is 4. Okay. Can I find the density? Yes, I definitely can find the density. Density equals mass over volume. We have the mass 96.3, 93.6 over the volume, which is 12. 93.6 divided by 12 is what is around 7.8 grams per centimeter cubed. Okay. A slope is made by resting one end of the plank on a uh, wood on a block. Okay, the students use a digital stopwatch to record the time. Now we have the time. What is the time? What is the time? 6.14. What is the second time? 6.28. That's quite easy. 6.28. Okay. Can I find the average time? Yes, I can find the average time. 6.14 plus 6.28 over 2. 6.14 plus 6.28 over 2, which has an average time of 6.21. 6.21. The students want to want centrally to take more time. You need it to take more time. Suggest how the students can alter this arrangement. How can they change this arrangement in order for the trolley to take more time? Okay, how can it take more time? If you look at the if you look at the figure, can I change the slope of this plank? Yes, definitely. I can change the slope. How can I change the slope? By decreasing the height of the wooden block, or by decreasing, you can say decreasing the length of the wood. No, actually decreasing the length of the plank. If you decrease the length of the plank itself, okay, it would decrease the time. You need to increase time. If you mean if what you mean is decreasing the height of this wooden block, then it would be correct. Yes, decrease the height of the wooden block or decreasing the slope as a whole. Okay, decrease the slope by decreasing the height, the height of the wooden block. . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . Okay. A different trolley travels 1.2 meters down the slope at a time of 7.8 seconds. Calculate the average speed. Average speed equals total distance over total time. Total distance over total time. So you have 1.2 divided by 7.8. Average speed, you need to write down the equation equals total distance over total time. 1.2 divided by 7.8, which gives you a final answer of around 0.15. 0.15 meters per second. Okay, this is while it's traveling down a different slope. We have a speed time graph down a different slope. Can I find the distance traveled between 0 and 4? Can you find the total distance? Total distance using a speed time graph. How can I find the distance using a speed time graph? Distance is area under the graph. Area under the graph. How can I find the area under the graph? This is a triangle. So basically half times base times height. Half times 4 times 1.6 times 1.6, which is 3.2 meters. Half times base times height. A student determines the center of mass. Okay. Describe how the student can determine the center of mass using this equipment. How can he use this equipment to find the center of mass? First of all, you need to draw a line. Already the weight is already attached to the cotton thread. It's already there. So can I draw a line using the ruler along, it's a horizontal line. Sorry, it's a vertical line, not a horizontal line. So I need to draw a vertical line along the thread. First of all, you need to draw a line, okay, along the thread. So drawing a line, draw a vertical line along the thread with the pencil, with the pencil. Okay, so first of all, draw a vertical line along the thread with the pencil. After you draw this line with the pencil, what should you do? You need to repeat the experiment, okay? You need to hang this piece of lamina from a different corner, from B or from C, okay? Hang this, um, it's a card. Hang the card, hang the card from point B, miss. Okay, from point B. Then repeat the experiment. The line, no, repeat the experiment by drawing another line. You have to draw at least two lines, at least two lines. By drawing another line, the center of mass, first, the center of mass is the point of intersection of these two lines. Okay? Drawing a vertical line and then repeating the experiment from another point. The intersection of these 2 points or these two lines would be the center of mass. Another card is pivoted from P, and a force of 1.4 acts at a distance of 20 centimeters from P. Can I find the moment? Okay, that's easy. Moment equals force times perpendicular distance, which is 1.4 times 20. 1.4 times 20 is 28 newtons per centimeter. A substance cools from 50 degrees Celsius to 5 degrees Celsius. Okay, so we actually need to draw a curve. Need to draw this cooling curve. Cools from 50 to 5 degrees Celsius. Its melting point is 20 degrees Celsius. Melting point is 20 degrees Celsius. So initially, if you think about it, if it's cooling from 50 to 5 degrees Celsius and the melting point is 20 degrees Celsius, melting point, while cooling wouldn't be called the melting point, it would be called the freezing point. It would be called the freezing point. Why? Because you're cooling. It's the same point, it's the same temperature. While cooling, a substance cools from 50 to 5 degrees. Its melting point is 20 degrees. It takes 30 minutes to cool from 50 to the melting point. Takes 30 minutes to cool from the to cool from what? From the 50 degrees to the melting point. So first of all, can I draw this part? Can I draw the part from 50 degrees, which is at this point? This is 50 degrees to 20 degrees, which is the freezing point. 20 degrees after how many minutes? After 30 minutes. So after 30 minutes, it has reached this point, 20 degrees. It has cooled. It has cooled all the way to from 50 to 20 degrees Celsius. After how many minutes? After 30 minutes. After 30 minutes. The substance takes a total time of 80 minutes to cool from 50 to 5. From 50 to 5. Question is, should I continue a straight line? Should you continue a decreasing slope or whatever, constant slope from 50 all the way to 0 or to 5 degrees? Should you continue all the way? No, you shouldn't. Why? Because when you reach the freezing point, it takes some time. It takes some time for the for the slope. Takes some time for the substance to change from liquid to solid. Takes some time. This is the freezing process. The freezing process takes whatever. He didn't specify what was the time taken for this substance to cool down or to actually not cool down, to freeze. He didn't specify what was the time taken for the substance to freeze. What time should I draw it? For example, I need to draw now a horizontal line. You need to draw a horizontal line which indicates that this substance is freezing. Should I continue this line for how long? 10 minutes, 20, 30, 40 minutes, whatever. Okay, whatever. You just need to draw a horizontal line. And then, after you draw this horizontal line, you need to decrease the time and decrease the temperature all the way to 5 at this point. At this point, it has reached 5 degrees Celsius. It has reached 5 degrees Celsius. So this is what we call a cooling curve. Initially, you had liquid cooling. This is liquid cooling. You don't need to label it. Okay, and this is the freezing process, and this is a solid cooling or decreasing temperature of a solid. Okay. Describe the arrangement and motion of the molecules in a substance when they are in a solid state. Okay. Can I repeat it? Okay, I can repeat it again. Quickly from he said that the substance starts at 50 degrees Celsius. It starts to cool. It starts to cool. Okay, it's a liquid. Initially, it was a liquid. Initially, it was a liquid, and the liquid was cooling from 50 all the way to 20. Why did I stop at 20? Because 20 is the melting point, which is also the freezing point. So it cools from 50 all the way to 20. Then you stop. This is the liquid cooling as it's changing because after it reaches the melting point, it will start to change from liquid to solid. So at this point, we can call it the freezing point. This is called the freezing point. Okay, this is the freezing point. You do not need to label these points. As it freezes, it takes some time. How long should it take? Whatever time. Whatever time. Okay, you just need to indicate that it's freezing for a short amount of time. Well, for some time, 10, 20, 30 minutes, whatever. Okay, this is the time taken for this substance to cool. And then after it cools, okay, after it changes completely to solid, it will start to decrease its temperature, starting from 20 all the way to 5 degrees Celsius. Why? Because he wants to stop at 5 degrees Celsius. Okay, I hope it's clear now. Describe the arrangement and motion of the molecules in the substance when they are in a solid state. Arrangement and motion. Definitely the motion. What do we say in the motion? They vibrate in fixed space. And then, what about the arrangement? They are close. They are close together. A regular arrangement. You can say it has a regular arrangement. They are close together and they vibrate in fixed place. They vibrate in fixed place. Okay. Figure 5.1 shows a plastic bottle on a bench. The plastic bottle contains liquid. Can I find the pressure on the bench? Can you find the pressure on the bench? Pressure equals what? Pressure equals force over area. Force over area. What is the force? 12. And what is the area? 25. So 12 over 25 is 40 or 0.48 newtons per centimeter cube squared. 0.48 newtons per centimeter squared. Yasmin pours all of the liquid outside the bottle. She then connects the bottle to a vacuum pump, which removes most of the air from the bottle. Okay, explain why the bottle is crushed. Use ideas about molecules. As you remove all of the air from the bottle, why is it crushed in this way? If you think about molecules, okay, if you think about molecules, how do molecules move? Okay, first of all, how do air molecules move? They move fast and random in all directions. Okay, I'm talking about the air molecules outside the bottle. They move fast and random in all directions, colliding with the surfaces of this bottle, exerting a force over an area which is the pressure. So basically, I'm just kind of explaining what is pressure, and then I need to state that there are more molecules from the outside than the inside. Therefore, there's a higher pressure from the outside than the inside. That's why it kind of collapses inwards. Okay, that's why it implodes. We say it implodes. So air molecules move fast and random, fast and random, colliding with the surface of the bottle, exerting a force over an area which is pressure. You can say that the outside pressure is greater than is greater than the pressure inside, and the pressure inside, that's why it collapses due to more molecules being outside than inside. Okay, due to more molecules being outside the bottle than inside it. Hmm. Okay. Yeah. State which letter represents the wavelength. From crest to crest, which is R, represents the amplitude, P. What is meant by frequency? Frequency is the number of waves per second. number of waves per unit time or per second. Number of vibrations per second, number of waves per unit time. Two students, A and B, use echoes to make measurements of the speed of sound. Describe how the students can use the arrangement to determine the speed of sound. Determining the speed of sound. First of all, you have student A and student B. Student A has the blocks of wood, and student B has the stopwatch. What should they do? First of all, A will just bang the blocks of wood. B has to start the stopwatch, and then when B listens to the sound again, when B hears the sound again, what should she do? She should stop the stopwatch. Okay? And then we can calculate the speed equals 2 distance over time. 2 distance over time. Why? Because the, traveled all the way to the school wall and then back, total distance of 240 meters. Okay, so now we can say, yeah, student A hits the blocks of wood, hits the blocks of wood together. B, student B starts the stopwatch. Oops. Okay, student B starts the stopwatch when he hears, or she, when she hears the sound again, the sound again, she stops the stopwatch. She stops the stopwatch, okay, and records time t. She records time t. Calculate the speed to distance over time. To distance over time. And then you can say repeat and take average. Repeat and take average. Okay? Okay. Question 7. You have the ray of red light. Okay? Ray of red light. Draw the path of the refracted ray into air as it refracts into air. So I'll just draw a ray with an angle greater than the angle of incidence. Where's the angle of incidence? This is the angle of incidence, and this is the angle of refraction. It needs to be clear that the angle of refraction is greater than the angle of incidence. Okay, 3 very easy marks. When the angle of incidence is at 70, the ray does not emerge from the glass into air. Why? What happens to the ray X and why this happens? Why does this happen? The angle is too large. If the angle is too large, what happens? Total internal reflection. Total internal reflection. In which? Total internal reflection. In which? The angle of incidence. The angle of incidence is now what? Is greater, is much greater than the critical angle. Critical angle. Okay, that's why total internal reflection occurs. Compare the speeds and the frequencies by completing this sentence. Speed of visible light is what compared to the speed of X-rays? Electromagnetic waves, they all have the same speed. The same speed. صح. They are equal. Is equal, yes. What about the frequency of light compared to the X-rays? Frequency of the light compared to the X-rays. Ah, it is less. Okay, is less than the X-rays because X-rays, gamma rays, ultraviolet, they all have frequencies which are greater than the visible light. Describe one use of X-rays. One use of X-rays is what? Scanning for broken bones. Yeah. Scanning for broken bones. On figure 8.1, label the north and south poles of this magnet. North pole has to be on the left side and the south pole has to be on the right side. Why? Because the arrows are going outside from the north pole and are going inwards at the south pole. A soft iron bar is positioned as shown. This is the soft iron bar. State and explain what happens to the soft iron bar. Iron next to a magnet. Iron next to a magnet. It will definitely be attracted. Why? Because it becomes a magnet with opposite poles. Becomes a magnet with opposite poles. So for example, if this is the south pole and this is the north pole, then this would have a south and this would be a north pole. Why? Because it's a temporary magnet. It gets magnetized easily. Okay? It gets attracted. Okay? Gets attracted to the magnet. Why? Because you can say that you can say that magnetic poles, okay, are induced in the iron, which are opposite. Opposite meaning that they will attract. They will attract. A plastic rod is rubbed with a cloth. The plastic rod becomes positively charged. As it becomes positively charged, explain how the friction between the cloth and the rod causes the rod to become positively charged. Positively charged means it gained or did it lose? Did it gain or did it lose? Positively means it lost. So it lost electrons to the cloth. Lost electrons to the cloth. A plastic is an electrical insulator. Iron is an electrical conductor. State two other materials that are conductors. Literally any two other materials. You can say copper. You can say aluminum, gold, silver, whatever, steel. They are all electrical conductors. State the name of instrument used to measure the potential difference. The potential difference. What is the instrument that measures the potential difference? It is the voltmeter. Can you tell me what is the unit? Unit of the potential difference. Unit of the potential difference is volts. Yes, volts. Excellent. Okay. Yes. Can I find the resistance? Yes, I can find the resistance. R equals V over I. R equals V over I. 6.4 over 0.2. Okay, 6.4 over 0.2, which is 32, I guess. 32. ماشي. Ohms. The student has some wires in the same material, but of various lengths and thicknesses. He wants a wire with the higher resistance. He wants to increase the resistance. How can he increase the resistance? Two ways of identifying the wire with a high resistance, comparing its length and thickness. To increase the resistance, what should I do to the length? I need to increase the length. You need to increase the length. What about the thickness? You need to decrease the thickness. You need a thinner wire. You need to decrease the thickness. A thinner wire. Okay? Hmm. A student wants to demonstrate electromagnetic induction in a wire. Describe how the student uses the equipment. He has a length of wire, a sensitive ammeter or galvanometer, and a permanent magnet. A length of wire and a permanent magnet. What should he do? What should he do? He should connect the wire to the galvanometer. He should connect the wire to the galvanometer and start moving the wire up and down. should okay, if you remember the drawing in which we had the North Pole and the South Pole, and then we had the wire which was connected to the voltmeter or the ammeter or the galvanometer, and then you started moving the wire up and down. So connect the wire to the galvanometer. Okay, move the wire up and down. Move the wire up and down, perpendicular to the magnetic field. Perpendicular to the magnetic field. Magnetic field. State two ways in which the student can increase the size of the induced EMF. How can he increase the size of the induced EMF? You have three ways. For this question, what can I do? You need to increase the strength of the magnet. You need to move it faster. I need to increase the number of coils. How can I increase the number of coils? By basically turning the wire, turning this wire into a coil. Okay, so if you increase the number of turns, it would increase the voltage, the induced EMF. So basically, you need to increase the speed of motion, increase the speed of motion. You can also increase the magnetic field, or you need a stronger magnet. A stronger magnet. Increase the current would be wrong. Why? Because you want to increase the induced voltage. You want to increase the induced current. You want to produce a current. So how can you produce a current by increasing the current? It's not logical. Okay, so I need to increase the strength of motion, okay, the speed of motion to produce a current. Induced current means produced or generated current. Okay? We have a DC motor. It's rotating. On figure 10.1, run arrow between poles to show the direction of the magnetic field. Magnetic field is always from the North Pole to the South Pole. From the North Pole to the South Pole. State two ways of making the coil spin faster. Making the coil spin faster. In this question, you can say increase the current. This question, you can say increasing the current. Why? Because the current will make the coil rotate. This question, this is a DC motor, so you're kind of using or changing the electrical energy to kinetic energy. Electrical energy to kinetic energy. While in the other question, you're changing the kinetic energy to electrical energy. So you can say increase the current. You can say a stronger magnet. Okay, you can say a stronger magnet, or you can say increase the number of coils in the coil. State one way of making the coil spin in the opposite direction. How can I make it spin in the opposite direction? You have two ways, either by reversing the current or by reversing the poles of the magnets. Okay, reverse the current. Probably reversing the current would be easier because all you need to do is switch the poles of the battery. Switch the connections of the battery. Question 11. Okay, this is a nice question. The largest mass is the alpha particles. Okay, the most ionizing would be also alpha particles. The most penetrating, definitely not the alpha particles, gamma. Negatively charged, Beta. Greatest speed, which is 3 times 10 to the power of 8. Greatest speed. Speed of light. A sample of radioactive material contains 80 milligrams. Half-life is 15 hours. Find the remaining sample after 45 hours. After 45 hours. So basically, you need to divide the total time by the half-life, which is 3 half-lives. This means that you have three. What do I mean by 3 half-lives? Means that I will divide by 3. No, divide by 2. How many times? 3 times. Divide by 2, how many times? 3 times. So 80 divided by 2 is 40. Again, divide by 2, it's 20. Divide by 2 again is 10. So the remaining mass is 10 milligrams. Okay? Okay.